All right, it's 11:10. Let's get started. Welcome to Day 8, Lecture 4. Today we're going to be talking about data types and announcements. As you can tell, there's still construction. Nothing like the sound of construction to wake you up in the morning. How many of you guys have run into problems with Jupyter Hub in the past week? Ooh, great. Yeah, so we're really sorry about those technical difficulties. Apparently hostage computers are not as reliable as we thought they would be, but we have people working on it, and hopefully by next week we'll get everything really sorted out so that we will get a lot less issues in the future. But as for now, the best I can do is say, let's hope for the best. Just a reminder that the welcome survey is due tonight. On the website, it previously said due tomorrow night. Unfortunately for you, it is due tonight. But fortunately for you, it doesn't take too long. So go ahead and make sure you do that tonight in order to get credit for it. Homework 1 is due tomorrow night at midnight, as usual. And homework 2 will be released tonight and will be due on Monday night. There will be tutoring sessions starting next week. So tutoring sessions are 45-minute small group sessions where you and maybe about 5 other students will sit down with our tutor, Emma, and you guys will go over and practice the concepts that we went over in the last week of class. If you feel like you need the extra review and practice, I suggest you sign up. Sign-ups are available on our website, and they're especially helpful for those of you who are feeling lost, confused, don't want to hear construction while people are talking. Okay, so all of that will be helpful to you. All right, let's get right into it. So today I'm going to be talking about call expressions. Yesterday we talked about arithmetic expressions, so like 1 + 1, 1 × 2, all of that stuff, and we worked mostly with numbers. Call expressions allow us to work with Python's functions, which allows us to do more things than just adding or subtracting or arithmetic. As usual, I'm going to be working on data8.hos. I already have it. And I'm going to be making a new notebook. Hopefully data8.hos stays alive while I work on this lecture today. 4. Okay. Oops. Okay. So the way call expressions work, as you guys may know if you've gone to lab, is you write the function name first. So in this case, I'm taking the absolute value. And then you write parentheses. And then in the parentheses, you write the function's inputs. So in this case, I want to take the absolute value of -12, which gives me 12. So some vocabulary terms that you should be familiar with. So this is called the function name. Okay, so a function is kind of like a recipe for doing something. It's kind of like a verb in the English language. Okay, so values in Python are kind of like nouns. So table, chair, desk are kind of like the values in Python. So like -12 or 2 or 2.0. And functions are kind of like verbs in Python. So taking the absolute value, rounding another number, doing something to something else, that's what we use functions for. So in this case, we're taking the absolute value of -12. -12 is the input to the function, or what we call the argument. Why is it called the argument? Well, sometimes you get mad with your function, so you want to try to make it work. You get into an argument with it, so here's the argument. So you'll hear me use the terms input and argument interchangeably. And because this is a function, you'll also hear me use the word function call as a synonym for call expression. All right, so function call expression, same thing. Inputs and argument, same thing. You'll just hear me use those, so just be prepared. Someone asked me yesterday about how to reduce the number of decimal points in a number. So if I have what do I do? Okay, that. Okay, so if I want to reduce the number of decimal points in a number, so let's say I have 5 - 1.333, and let's say I want to round it. Well, Python has a function for that. It's called round. So round, and I get 4. Round can also take in a second argument. So if I do 5 - 1.333, comma 2, what that's saying is the first input to my function is the result of 5 - 1.333. And the second input to my function is 2, then it will round it to 2 decimal places instead of 0. So what's going on here is that if I have a sub, so it's possible to put sub expressions in the function call. what Python will do is it'll evaluate what's inside first, just like before we had parentheses. Whatever's in the parentheses will get evaluated first, and then the function will be called. So how this actually happens is Python will calculate 5 minus 1.333 and then replace it with 3.667, and then call round on 3.6667, and then replace that with 4. And when we call a function, the function evaluates to a value, and that value is what we call the return value of the function. Okay, so the function's return value is also what the function becomes. Cool. There are other types of functions. So the max. So if I have max and I give it a couple of different arguments, then it will give me the max of all of them. Okay. Another example of a function with multiple arguments. Some functions have one argument, like absolute value. So if I try to do the absolute value of -12, comma 7, this will actually give me an error. Okay? And it will tell me that the error is that absolute takes exactly one argument, and I gave it 2. Some functions can take in 1 or 2. So you saw before that round can take in 1, and a round can take in 2. And some functions can take in any number, like max. So max, I can actually just keep adding numbers here, 8, 9, 10, and it'll give me all of those. Okay? But most functions are pretty picky about the number of arguments that you give it. So just be careful and think through kind of what the function is doing as you're typing it out. And do be aware that you will get type errors like about argument numbers as if you mess up the number of arguments to a function. Cool. So these functions are already available in Python. But most math functions are not available right away. What you have to do is you have to grab them from what's called a package. So if I do import math is a package that has a bunch of useful functions that basically give Python the ability to be a calculator. So for example, I can take the square root of a number. So the way to call a function from a package is the package name dot and then the function name. But once I have the function there, I can just call square root of 9 and get 3. If you recall from yesterday, it's the same thing as doing 9 times 0.5, and I also get 3. Okay. So math, the package has a bunch of useful functions. One way I can find out what functions are available to me is I can do math dot, and in Jupyter I can press tab. Okay. When I press tab, it'll show me a list of all the available functions in the math package. So really useful if you're having trouble remembering a function, you can go ahead and press tab. Here's a list. Okay, so for example, I can take math.sine, and I want to take the sine of pi over 2. The math package also has constants such as pi. So I'm going to look for pi. The other way of doing this is to type, and as I type, you'll see that the list shortens down to what I've typed. So pretty useful, save a lot of time if you don't remember what the function or the value is called. So math.pi divided by 2. If you remember, sine of pi over 2 is 1. Okay? Cool. So another way of figuring out, another useful thing to know is that, let's say I'm trying to do the log of something. So you know there's a couple of different logs here. And if you remember a logarithm, you can have different bases in a logarithm. Okay. So let's say I don't remember whether the default math.log is base 10 or base of e or base of 2 or whatever. What I can do is I can type the function name, but before typing parentheses, I can type question mark. Okay. So I want to know how it works. How does log work? Well, right here, Jupyter will show me what math.log does. Return the logarithm of x to a given base. If the base is not specified, return the natural logarithm base e of x. Okay, so really handy. If I forget how the function works, question mark, and it'll show me how it works. I can do this with every single function that you've seen so far. So I can do abs question mark, and it would say return the absolute value of the argument. Really handy. Okay, so remember that question mark. It'll serve you well. So one thing I want to note here is that you'll see that it also. So the documentation, this is what's called documentation. The documentation also shows me how many arguments the function takes in. What these brackets mean here is that this argument, so that means that log can take either 1 or 2 arguments. The first argument is required. So if I want to call it, I have to pass in at least one thing. If I pass in nothing, it'll give me a type error. If I pass in log of 1000, it will work. And you'll see this bracket thing here. So this bracket thing means you can also take in a second argument, which is the base of the logarithm. So if I want to take the log base 2, I can just do comma 2. And documentation shows me that math.log takes in either 1 or 2. Okay, so also really handy for that. If I want to get rid of it, I can press the X here, or I can just press escape a bunch of times and it'll disappear. Okay, so math.log of 1000 is that. And just to make sure, I can do math.pow. And so logarithm, the natural log of 1000 means that e to the power of this number should equal 1000. So I can take e to the power of that number, and that should give me 1000. It doesn't give me 1000, but that's because of numerical precision, if you remember from yesterday. So this right here is what we consider just 1000. Any questions about what I've done so far? Yes, name any question? The question mark, sorry, your name was Luke, right? So Luke says the question mark doesn't work on the interpreter of your own computer. So are you typing Python in your command line? Okay, yeah, so the question mark thing, so if you don't know what I just said, don't worry about it. The question mark thing, just know that this will only work in Jupyter. If you happen to know, if you happen to take another Python class before, they've probably told you to use a Python interpreter. The Python interpreter doesn't have nice things like the question mark, and that's why I like Jupyter. Yes, name a question.
I'm Emily, and then the 6.9, that number, like the second argument that you put in line 19. So what was the point of that? Like putting the second.
Sorry, so this one right here?
Yeah. Like
So Emily asked, why do I have another thing here? Well, that's because math.pow takes in 2 arguments. I can figure that out by doing question mark.
Oh, it's e to that power.
That's right. So what it does is it does e times y, or e to the power of y, or x to the power of y. That's right. Great question. Yes, name a question.
Kevin, why did you just use 2 stars as for power?
Yeah, so Kevin asked, why didn't I just use 2 stars instead of math.pow? No reason except I want to show you that there is a pow function. That's it. Normally I would use star. Yeah, Kevin again?
Yeah, and also if you do math dot whatever, does it always produce a float?
So Kevin asks, does math dot whatever always produce a float? I think most of the functions here do produce floats, but some of them don't. You have to look at each function individually to figure out which of them produce floats and which of them produce integers. Yeah, but each function can technically return whatever it wants. Great question. All right, let's move on. So just to recap, the way call expressions look is f right here is the function name, and then we do parentheses, and then we pass in argument number 1 and then argument number 2. In this case, this is a more complicated looking thing, but really, let's see. So this right here is one call expression, and right here is another call expression in the call expression inception. Okay, so f is a function to call, but really, when you look at this, you just need to say, okay, f is my function, x plus y is my first argument, the result of calling g on z is my second argument. And so if I wanted to read this whole thing as a sentence, I could say call f on the result of adding x plus y, the return value of calling g on z. But really, when I'm thinking about this in my head, what Python does is it says, okay, I'm going to call f, parentheses go first, so x plus y, compute that. So let's say x plus y is 10. Okay, so Python says, okay, that's 10. Then move on to a second argument. Calling g on z produces another thing. Maybe that thing is 20. So I have 10 here and 20 here, and then I call f on 10, 20. And f and g here are kind of like just placeholders for this slide. But in reality, if you want to call this, you'd have to use actual functions. So like math.pow or an absolute value, for example, for f and g. Okay. So here's a discussion question. Assume you have run the following statements. Which of these examples results in an error? And there is at least one error. So keep an eye out for the error. Think about it to yourself for a couple minutes, and then I'm going to have you discuss with your neighbor. All right, go ahead and talk with your neighbor. All right, how many guys think A will error? How many guys think B will error? C? C will error? D will error? Not bad. Okay, so A will error because absolute only takes one argument. So passing in 2, as I demonstrated before, will give you a type error, too many arguments. B is fine. So absolute of y will produce 2, and math.pow 3 comma 2 is 3 to the power of 2. That's just 9. Okay. The second one here looks mostly good until you count the number of parentheses and realize that there's 3 here, but 4 here. Okay, so so this will get you. Okay, so if you're missing your parentheses or you have one extra, Python will yell at you. Python will give you a syntax error because your syntax is not correct. Okay, so you laugh at this example because it seems like trite, but it does happen. All right, yes, question. Sorry, I couldn't hear your question. Could you repeat it?
Would you get an error if there's only one argument in max, or that'd be okay?
That is actually fine, but Python won't even try to run max. So Python, before even trying to run anything, it will say, oh, too many parentheses, that bad news. Yeah. Question? Another question?
I ran it too, and it said type error float object is not iterable.
Float object is not iterable. I'm not exactly sure what that is, but maybe I can take a look after class. And D, okay, so just to finish off, D here. So D is fine because what happens is Python does, well, oops. Python will run x and say, okay, x is 3, that's fine. Move on to a second argument, math.pow y comma x is -2 to the power of 3, which is -8. And then math.pow 3 to -8 is fine. It's something small. Yeah, question? So the question was, can we just put one argument in the max function because max needs at least 2? Well, only one way to find out. Let's try it. So if I try to take the max of 2, it will give me an error. Indeed, an object is not iterable. If I try, so I need at least, it looks like I need at least 2. I can also find out by doing question mark again. So that's not, it looks kind of complicated, but you'll see that max here needs like at least 2 and then more. But yeah, sometimes the documentation is kind of confusing, but most of the time you can try to figure it out just by trial and error plus the documentation together. Cool. All right, let's move on. So far we've only talked about numbers. Let's talk about how to represent text because text is useful. So what we do when we want to represent text in Python is we create a value called a string. So now we have 3 types of things. Okay, so we have ints, we have floats, and we have strings. Technically, we've also seen packages, but we won't be like using packages as values for the most part. So just remember ints, floats, and strings so far. The string is a value that just contains text characters. Okay, so text can be any length. I can just have a letter A, or I can do a word. So the way the string works is I put one quote and then some stuff inside, and then another quote to finish it. It doesn't matter whether I use double quotes or single quotes. So if I want to, so here I use double quotes, I write a lot of stuff, and then I use double quotes here. What matters is that the quotes need to match. So if I use double quotes here, I need double quotes here. I can't replace it with a single quotes. So sometimes you get a string that contains a number. So for example, if you pull data off the internet, sometimes the numbers there will look like strings. So you can convert strings that contain numbers into the actual numbers by typing int, by calling the function int on a string that looks like a number. Okay, so int 12 will produce the integer 12. Float of 1.2 will produce the float 1.2. any value can be converted to a string. So if I do, using the stir function, so if I do stir 5, what I'm going to get is a string with the number 5 in it. So it's a string with number 5. Okay. So let's do a short demo. And that. Okay. So I'm showing you how to create a string. So here's data. If I happen to add strings together, what Python will do is it'll actually just it'll just smash the strings together into one longer string. Okay, so here's one string, here's another string, and here is a resulting single string which just contains data 8 all in one string. This is not okay. And what happens here is Python will yell at me with a syntax error. Why that happened? Well, because I tried to do an apostrophe here for its, but Python thought that that closed the string. So you see the highlighting here, like the red is for a string and the black is for other things. Python thinks that I ended my string there because it ran into a single quote. So I write a single quote, write some text, another single quote. Python thinks my string ended. And then this right here doesn't know what to do. And then I have another quote here, so Python just freaks out and gives me a syntax error. Okay, but this is okay. So if I do double quotes, I can now use single quotes in my string because only another double quote will finish my string off. It's okay. It's okay. Yeah, question.
Is there any escape character in Python?
Are there any escape characters in Python? Yes. So for those of you who don't know what an escape character is something that allows me to use. So let's say I have for some reason I have to use single quotes. I really love single quotes. If I really want to use a single quote, then what I can do is I can do a backslash here, and that Python will treat that as like the character apostrophe, not the ending to a string. So this will actually be okay. So backslash is your escape character because you escape from Python interpreting it. But for our purposes, you won't really have to worry about it. Just remember to use single quotes or double quotes, and you might run into an error if you have single quotes or double quotes in your string. Another question? Okay, cool. So let's do another discussion question. All right. So suppose I ran the following statements. All of these lines error. What is the reason that each line errors? Please think it over for a minute. All right, talk it over with your neighbor. All right. So in the interest of time, I'm just going to tell you the answers. So x plus y. This errors out because x is an integer, but y is a string. You can't add integers to strings. This is a case of like when you're trying to mix together types of things. So we have like ints, floats, and strings. When you're trying to mix together the types, sometimes things don't work out. So you want to be careful with the types that you're working with. Okay. So in the second case, y plus z works okay, right? It's because I can add strings together, and it'll become 45. It'll be a string with 45.6. When I try to take an integer of that, it's not a valid integer, so it'll error out on the integer part. Okay. Here I convert x to a string, so now x is a quote 3, and then plus int y, so that becomes an integer 4. But now I have a string plus an integer. That Python will complain about that as well. finally here, stir only takes in one argument, so passing in 2 arguments here will also cause an error. Okay. Now, I mentioned before that you'll get problems when you try to mix together types of things. So we've covered a couple of different types of things so far. Here's an integer, here's a float, and Python has a function called type that will tell me what type of thing I'm passing in. So type 3 is an int, type 3.0 is a float, and type of quote 3 is a string. Okay? Type of quote 3, the word 3 is also a string because anything inside quotes is a string. So adding together ints is fine, adding together strings is fine, but adding together a string, or adding together an int and a string is a problem. It'll give me a type error. It'll say I can't do plus on int and stir. Okay? So what do you guys think will happen here? Talk over with your neighbor. What happens if I type that? Will that work? If so, what will it become? If not, why won't it work? Okay, so does anyone have a guess as to what happens if I run this? Yes, Kevin.
The outcome will be 39.
The output will be 39. Well, let's see if he's right. And he's right, it is 39. What happened? Well, Python does the stuff in parentheses first, so it does 3 plus 4. The string 3 plus the string 4 becomes a string 3, 4. And then int of the string 3, 4 becomes 34. So just to convince you guys, so the string 3 plus the string 4 is 34. The int of that is an int 34. And then finally, I add 5 to the int 34, gets 39. Okay. Cool. Now, there are other types of things that we haven't covered so far. For example, if I do 3 greater than 2, I get the value true. But 2 greater than 3, I get the value false. These values are called Boolean, so they just represent true or false, trueness or falseness. We won't be doing them too much in this class, but I just want you to be aware that there are more types out there than what I've covered so far. Cool. And now I believe I take out a discussion question. Great. Okay, so I want to give you guys a note on the difference between function calls and method calls. So strings have these things called methods that you can call. So for example, let me just pull one from here. I look at hello, and I want to count the number of times the letter L appears in hello. I can do string hello.count it's a string of L. Okay. If I want to replace a string, so if I want to do hello.replace, replace is a method that lets me replace one argument with the second argument. So I can do helpo. Okay. So this looks a little bit different than the syntax you've seen so far. I want to call your attention to it because they're slightly different from each other. Okay, so typically we use the terminology function to refer to what we've seen so far, which is like abs, int, and round, max, etc. Okay, so those are what we call functions. What we call methods are kind of like functions, but they only work for a particular type of thing. Okay, so in this case, I have a string. Okay, so the count method only works on strings. So I have the string hello.count2. I can do Sam is kind of cool, replace kind of with very to make a true statement, which is Sam is very cool. And math.pow is kind of like a method because I have the package here and I do .pow 2, 5. So typically a method call is something in front dot the actual function. Okay, a function is just called on its own and it exists in its own space, but a method only works on particular types. Okay, so only strings have the count method. you can't call count on, you can't call count by itself. You have to do string.count. That's the way it works. All right. Now I want to talk about arrays. And I first want to start off with the reason why we want arrays. So far we've been working with individual numbers. So for example, let's say we're trying to keep track of how many friends the course staff has. Okay, so let's say Nancy has 4 friends, Arvin has 5 friends, Catherine has 2, Emma is popular, so she has 10, and I have 0. Okay. And let's say that all the course staff meet each other and prepare for this wonderful class called Data 8. When they meet each other, everyone's friends will go up by 4, right? Because I meet Nancy, Arvin, Catherine, Emma. Nancy meets everyone else. We all meet each other, so all of our friends go up by 4. So to keep track of the number of friends we have, I want to do Nancy equals Nancy plus 4. So I can add 4 to whatever Nancy had before. So now Nancy will get 8 friends. Arvin will get another 4 friends. Catherine will get another 4 friends. Emma will get another 4 friends. And you can quickly see that this is becoming annoying. Equals Sam plus 4. And lo and behold, I now have 4 friends. Yay, friendship. Okay. Now this is kind of a pain, right? You notice me typing this stuff over and over again. Typically, when you have to repeat yourself a bunch of times, there is a better way to do it. In this case, it's better to operate on a collection of numbers rather than a single number at a time. This is why we have arrays. So I can take the number of friends we have and make it an array. So to do that, I just call a function called makeArray. And Nancy had 4, 5, 2, 10. So I can keep track of the number of friends each person has in one place in one value called an array. Now, when I run this, this will break. And that's because I need to import the makeArray function. To import the makeArray function, I just do from data science import star. Don't worry about the syntax too much for now. Just know that we put this line in the beginning of almost every single assignment you'll see from now on. The reason why we put that line there is to give you access to functions that we've created for you. So when I do that, now I get access to the makeArray function. And when I do that, I get an array. Nice. Now the cool thing about arrays, let me save this as a variable called friendship. Friendship is great. Okay, so friendship and friendship is there. Okay. Now what I can do is instead of having to type Nancy plus 4, Arvin plus 4, Emma plus 4, Sam plus 4, I can just do friendship plus 4. And what Python will do is it'll take that array and do the plus 4 to every single thing inside the array. Okay, so very sweet. It's the power of friendship and arrays. Cool. How much time do I have? All right. Let me run through a quick example. So just to recap, an array contains a sequence of values. And the thing about arrays is that all the values inside the array need to have the same type. Okay, so before I was counting friends, all of those numbers need to be ints. On the other hand, if I was keeping track of strings, I can also put strings in an array. Everything inside the array needs to be a string. Okay, so everything needs to be the same type. And when I do arithmetic to the array, every single element, it happens to every single element. So it saves me from having to repeat myself like 5 times. I can just say plus 4 once, and all 5 numbers would get the plus 4. Very convenient. Another convenient thing about arrays is that if I have 2 arrays, and the arrays are the same length, if I add them together, each pair of numbers in the 2 arrays will get added together to make one final array. Okay? And I'm going to show you how that works with an example here, taken from berkeley-earth.lbl.gov, which is from my very own Lawrence Berkeley lab. Here they've kept track of climate change, or the temperature of the Earth. Okay? So right here is the global land temperature since it's 1750. Over here is the number of temperature stations they put around the world. So right now they have a bunch. They have like 10,000 temperature monitors reading temperatures around the world. So they have a pretty good sense of what the temperature of the world is like. And right here is a graph of the daily high temperature, like the average of that over a bunch of years. So they have a bunch of data there. And we can see right here that the temperature of the world is going up. Yay, global warming. Okay, so what I can do is I can grab that data. And right here, you see the data. and it's really complicated. I'm not going to make you read it all. I'm just going to tell you how it works. So the way it works is you have kind of like the global average temperature over, say, this 30-year period. And what they do is they measure the temperature of all the years in relation to that. Okay, so they said that the average temperature is 14.48 degrees Celsius. They have a pretty good sense of what that is because they say plus minus 0.06, which is pretty accurate. And if the temperature in the year 2000 was like 20 degrees Celsius, they would write plus 6, okay, so positive 6. So the way it's represented is there is what's called a baseline high. And that is the average temperature that they're measuring with respect to. And what I can do now is I want to look at the temperatures in 1850, in 1900, 1950, and 2000. These things right here, the hashtag thing is called a comment in Python. How this works is anything after the comment is ignored by Python. It's useful for making notes to yourself, for keeping track of what you did. So I can say hello date at 8, and Python will be totally fine with that because I can write anything I want after the comment. Python will ignore it, but it's there for me to read. Okay? And in 1850, so let's go here. Let's see, 5, 10 year. In 1850, it looks like the average temperature was about minus 0.88. Okay, so that means that the temperature there was the baseline high minus 0.80. Okay, that's the temperature in 1850. Let's look at the temperatures for everything else. I've already done that conveniently enough, and I believe it is minus 0.093, 105, 68, 4 plus. Okay. And the way making arrays works is every single element in the array needs to have a comma afterward in order to create an array for this. So if I do this and type highs, I now have an array containing the temperature in 1850, 1900, 1950, and 2000. So the average high temperature for that year. Okay. So as we've done before in lab, I can grab the first element of that. So I can grab the temperature in 1850 and grab it out by itself. But in reality, I want to kind of work with all the elements at once. That's why I created an array. So these are in Celsius. Let's convert them to Fahrenheit. So to convert something to Fahrenheit, I do 9 divided by 5 times highs plus 32. This will convert all the numbers in my array from Celsius to Fahrenheit. And we can see that the average high temperature in 1850 was 56 degrees Fahrenheit, and then up to 59 degrees in 2000. Okay, so it seems kind of high because in Berkeley it's like 75 degrees today, and we complain about the heat. But you have to remember that this is the average temperature over the whole Earth, and at the moment there's still a good amount of ice on the Earth. Okay, so the temperature seems low, but not that low when you think about it. Cool. So I can do stuff with arrays. So I can do len of highs to get the length. I can do the sum of highs, the sum of the temperature. So let's say I want to figure out how many friends each person has in total. I can also do friendship.sum. And that saves me the trouble from having to type in Nancy plus Emma plus Catherine plus Sam plus Arvin. I can just do friendship.sum, and woohoo, 21 friends. Everyone's a friend. Okay. There's also highs.mean. I can take the mean of the highs array by taking the sum divided by the length of the array. So I get 14 degrees. But, sorry, that's not. Is that right? Divided by length of highs. Oh, right, because it's in Celsius. So this is the average temperature in Celsius. But I can also do highs.mean and do the same thing. So nice little shortcuts there. Okay. So again, these are method calls. These only work on arrays. You can't do the mean of a string. You can only do the mean of an array. That's why the mean is a method on the array. All right, how much time do I have? Not that much time. So any questions about this? I'll take one question. Yeah, Kevin?
Is it possible to use sum if like the array is like strings, we'll just concatenate all of them to one really long string.
So is it possible to use sums if my array contains strings? Well, let's see if I can find out. Make array, and I can do hello world, and I can do .sum on that, and it gives me a type error, so it doesn't work. This error is really unhelpful because it says cannot perform reduce with flexible type. That's not helpful. So generally, you just kind of have to look at it and kind of say, okay, well that doesn't seem too right to me. Okay, so sometimes the error messages. So when we start working with arrays, your error messages start becoming really unhelpful. So you have to rely more and more on kind of your memory to figure this out. But that's kind of unfortunate, but that's the way the arrays are built. Okay, good question. Let's move on. So what I can do now is I can also take the low temperature. So they record not only the max temperature for the year, the low temperature for the year. So let's take a look at the lows. So I have the baseline low was 3 degrees. Lows. So again, I can do baseline low minus 0.872. So 1850, 1900, 1950, and 2000, as we did before. 0.629, 0.126, 78. Okay, so now I have the lows. And what I can do now is I can compare the highs and the lows. So as I mentioned before, if I have two arrays, so I have highs and I have lows, they have the same length. So I can do highs minus lows. And this gives me the difference in temperature that year for all 4 years I'm looking at. Okay, so very convenient. I don't have to type in like baseline high plus this minus this, baseline high plus this minus this. I can just do it in one go, highs minus lows, bam, 4 subtractions done. This is actually really fast. I can do this with a million numbers and it'll perform in like probably less than 0.1 seconds or something. So it's really fast and really nice and good for working with lots of data. Okay, so let's say I want to convert this difference to degrees Fahrenheit. I can again do 9 divided by 5 times highs plus 32 minus 9 divided by 5 times lows plus 32. And that converts the differences to degrees Fahrenheit. What you'll notice is that although the average temperature of the world rose year by year, it looks like the difference between the high temperature and the low temperature every year is about the same. So today it's on average warmer than it was in the 1800s, but there's still about a 20-degree difference Fahrenheit in between the high temperature of the day and low temperature of the day. So if today the high is like 77 degrees, then the low temperature today will be around 57 degrees. So I want to double check if that's true. So I looked up the map of, that. I want to click on this link, but this is blocking me. Can I do that? Okay, great. Click that, and I can click that. And what I have here is a map, 2 maps, let's see, of the nighttime surface temperature of regions of the world and the daytime surface temperatures. So nighttime, daytime, nighttime, daytime. And what you'll notice is that there are some regions of the world where around the equator mostly where like the nighttime temperature is warm and the daytime temperature is still warm. And there are some regions where, like Australia, where it's like kind of warm and then in temperature it's like blows up and becomes like really, really, really hot. Okay. But overall, you can kind of see it. There are some regions like they're all different, some regions don't get much difference, but overall the average is about 20 degrees. Cool stuff. All right. How much time have I got? Let's see. I can't figure out the time. It's okay. I have a clock there. All right. So typing all this stuff in. So you notice I typed in every single element of the loads right here. It's kind of a pain to type all those in every time. In general, we want to read in data from a website or some file that contains data instead of having to type in data manually. We'll be going over that tomorrow. Another way of creating an array without having to type in every single element is making what's called a range. Okay, so a range is a sequence of consecutive numbers. And the way to create a range is to say np.arrange. If I say np.arrange end, so if I do np.arrange 10, then it will create an array containing the numbers 0 through 9. So you'll notice that it won't contain the number 10, but it'll create from 0 up to end, but not including the number that it ends at. Okay, so this right here is another package called NumPy. We'll talk about that some more later, but you have to import the package NumPy, and then you can do np.arrange end, and this will create 0 up to end. So if I do end, if I put np.arrange 100, it'll do 0 to 99. Okay, so just keep that in mind. If I want to change where the range starts, I can add another argument called start. So if I do 2, 7, I'll get 2 to 6. Okay, and the third way of making a range is to do a third argument, which is step. So if I do, so step means go from the start to end, but only create numbers every step, like with step numbers in between. So if I do 1 to 100, so if I do start 1 and 100 with a step size of 5, then I'm going to get 1, 6, 11, 15, etc. Okay, so convenience for creating these things. All right. Let's see, got a couple minutes left. Just to recap, the range always includes start, but excludes the end. So if I'm stepping by 5, and I happen to step past the end here, I won't include that either. Okay, so if my end is 100, but I go from 97 to like 102, my array will not contain 102. It'll always stop before it gets to my end argument. Cool. So 2 minutes left. Let's see if you can figure this out. Okay. So talk this over with your partner. Assume you have run the following statements. Which of these lines error out? So remember that arrays will error if the lengths are not the same.
So it just is the range only one argument. The start point will be 0 or 1.
0. All right, so we're running out of time, so let me go over these really quick with you guys. All right, so X is make array 2, 3, 4. So as we discussed, make array will just create an array with the 3 elements 2, 3, 4 in it. On the other hand, if I do np.arange 2, 3, 4, what happens is it'll say make a range starting at 2 up to 3 and skipping every 4 numbers. So I'm going to start with 2, so I have 2 in my array. But when I add 4 to 2, it's going to go past 3. So it'll just stop there, and this will create an array with only one number in it, the number 2. This right here will create an array with the numbers 0, 1, and 2. So this one has 3 elements. Because of that, x plus y will error because y only has 1 element in it, and the number of elements in the array need to match up in order for you to take the addition. X plus z will be okay because there are 3 elements here and 3 elements in this range. X.item0 plus y.item0. So what happens here is I'm grabbing the first number of x2, the second number, and the first number of y2, and add them together, I'll get 4. That's totally okay. But if I take x.item1, what I'm doing there is I'm grabbing the second item of x3 and taking the second item of y, but y only has 1 item. So this will error out because y does not have item number 1. Okay? That's all the time we got for today. I'll see you guys tomorrow.